Tillmann Ohm. Where is Tillmann Ohm? He's already there, perfect. He's a creative technologist with a focus on curatorial systems. How do you actually pronounce that? You know what I mean? Systems that curate. He develops experimental tools and methods for the analysis and interaction with cultural collections. And he holds a diploma in fine arts from the Bauhaus-Universität Weimar, and he works as a cultural data analytics PhD research fellow at the Tallinn University. And I'm not sure, but we might have met in our past life. He doesn't listen, but we both studied in Weimar at about the same time, so, but we'll find out in the break. Okay, but now you're on with your lecture, Curatorial Algorithms and Collection Spaces, Tillmann. We're very excited. If the presentation works, I hope it does. Yes, it does.
Right. Okay. Yeah, good morning. Yes, thank you for this introduction. I just want to add maybe, what Kudan is, where I'm working recently. So I'm an artist by training and a research fellow at Kudan at Tallinn University. We are a multidisciplinary research group that is doing. It's not working. That is dealing with cultural data analytics, and as part of my PhD studies in information technology societies, I focus on curating digital collections using computational methods. So I'm mostly developing new methods for researchers and curators and tools, which revolves around the question, how can we navigate huge and explore huge collections of artifacts. Today I will give you a very brief overview of what I understand as collection spaces for curatorial algorithms. With that I mean two things, networks and vector embeddings, which in my view are very useful for algorithmic curation. There's actually a third one, network embeddings, but I won't tackle this today. So this talk will be very, very practical, about practical implementation on art and algorithms in a very playful and naive manner. So I will explain by showing examples from my own projects and the ones in collaboration with my colleagues. Starting with social networks, which are people-to-people relationships. This is clearly very central for curators. Then I will discuss my graduation project, the artist machine, which is based on co-occurrence networks. I should maybe, So people to concepts and RQ&O exhibition making is using semantic networks, so concepts to concepts with the use of external lexical knowledge from word embeddings. And after a quick interlude to introduce you to vectors, I will discuss some recent works which involves image embeddings, and then I will show you two demos on visualizations of high-dimensional spaces. And a research tool which will be released in a few days, the Collection Space Navigator. All right. In 2016, still at art school, I started to get interested in automation and algorithmic curation of artworks. So I wanted to establish an artificial curator, ARQ, that might curate an entire exhibition in the future. And at the time I believed in order to do that, it first needs to become an expert in a special domain and build its professional network around it. AI art was just about to take off back then, so ARQ started to gather information and on this machine learning art scene. So basically being a web crawler in the beginning, that would search the internet to find articles and events, gathering and structuring information. ARQ then got its own Twitter account to connect with people in the field, to retweet content, share art projects, exhibitions, articles, follow artists, and so on. So this established over the years a rather small social network, but with very important actors in the scene following ARQ and interacting with it. The project gets constantly further developed and is moving now to Mastodon and will soon become a networked search engine and curatorial platform for artists and curators. Then for me, the next logic step was to make ArcU graduate from art school. So for my graduation, I developed a workflow that allowed ArcU to write my thesis for me. I understand these acts of researching literature, analyzing content, and generating a publication also as curatorial processes. This also reflects on the research necessary prior to an art exhibition, for example. And these processes can be automated. So maybe I should emphasize that this is an art project that was meant to be provocative. So every time I'm showing this project, some people get offended, especially from the humanities. So I will just very quickly walk you through the several steps. So starting with an input phrase, here it was artificial intelligence in contemporary art. ArcU queries literature search engines and collect relevant publications. Now we have a text corpus which we can extract names and concepts from. ArcU retrieves additional information like the date of birth, which will become important later, but networks. So when entities, so concepts and artists, or concepts and people appear together in a sentence or a paragraph, we can assume that they have some kind of relationship with each other. So this forms a co-occurrence network. And doing this with the entire corpus, we first reduce it to the most important nodes, and for a second we only look at the people in the network. Then we perform some standard clustering network algorithm and detect communities with this. And so these topics, these communities are now the chapters of the thesis. So let's move on with one of these topics, one of these chapters. We can reintroduce the concepts and divide the network further into subtopics by detecting again communities. And if you remember earlier, we got information on the dates of birth, so we can build a linear chronological structure from which ArcU can then cite with the literature corpus it already got and stitch together text. So what's only left to do is to paraphrase it using machine translation. Then ArcU finds relevant figures and images to the text and compiles everything into a publication. If anyone is interested, I brought a few copies with me, so just poke me later. Then in 2020, ArcU finally curated its first art exhibition. This was part of the Kunstrepublik event at Halle 14 Center of Contemporary Art in Leipzig, with 13 artworks on display from the Kunstfonds of the Free State of Saxony of Staatliche Kunstsammlung. This is another ArcU and Ohm project, so it's again like not a completely autonomous system, but rather a machine-human collaboration. So the curating and exhibition making part had again networks involved. This will be an example for a semantic network. The dataset included keywords that were used by the artists to describe their own works, so we can already represent this as an artwork keyword network. And but because the keywords were not used consistently, some artworks would connect better than others. So for example, the keywords home and living to actually describe like similar topics, but they would not connect the described artworks. So that's why it's useful to enrich the network by providing semantic lexical knowledge about the keywords, so we can draw these is-related relationships between them, and this information comes from the multilingual lexical knowledge base ConceptNet, but in the form of word embeddings. I will explain in a second what this actually means. All you need to know right now is that we measure how close these keywords are in the semantic word space. So home and living, they are semantically very close. So yeah, now our network can also reflect this. And after creating these semantic network structures, the question is which artworks to select. And yeah, we can use multiple graph algorithms and construct our own. First, we detect communities again. Then we select the community cluster around the main topic of the exhibition, which was society. Then we select the, or we find path that connects all the artworks, so we can control also the amount that we want and run our community detection again. And finally, we can visualize these subdivided artwork topic networks within the floor plan of the exhibition space to arrange them in the room. So yeah, just a brief and very simple example of what vectors are and how they are connected to networks. So for everyone not so familiar with this. So let's say we analyze the text corpus and we found names of artists in it. And yeah, within the same sentences and paragraphs, some words are often mentioned together with the artist. So we can make such a table, a matrix of the co-occurrences between artists and concepts. So after normalization of the word frequencies, in the values could look like something like this, and from that we can create a co-occurrence network as seen before, and we connect like every artist with every keyword from the table. But we can already find vectors in this table that represents each artist. So each row encodes the features of an artist according to the methods and the databases we use to extract them from. And yeah, these vectors can be embedded into a metric space, and this yeah, in this very simple example, we have 4 features, so 4 values in a row that we call dimensions. So these are vectors with 4 dimensions. In reality, we rather deal with hundreds or thousands of dimensions. And the question is how to visualize them. Yeah, how to visualize 4 or hundreds or thousands of dimensions in 2D. So we need to reduce the dimensionality and project them into a lower dimensional space. And yeah, and these projection methods can be rather simple and linear, like principal component analysis, or more complex algorithms like t-SNE or UMAP. You will see them later in action. But we can not only embed words, we can also embed images. In fact, basically anything that can be represented as, everything can be represented as vectors. We just need to describe the features of an object numerically. So what is really important here, what it's all about, is how good we can describe these features. So luckily, vectors are needed for machine learning in order to produce, to process the input data. So we can take advantage of this and use very large already trained models or train our own. So here you see a simplified architecture of convolutional neural network that predicts some categories from images. And we have a part that extracts the features from the input image, and we have a part that does the classification. So yeah, all we are interested in is like this part, the feature extractions, to produce our representations. And yeah, and they produce then these long vectors again. Yeah, and when we extract feature vectors of multiple images, like from a large museum collection, for instance, we can measure the embedding space and make some basic calculations. So, for example, if you want to know which images resemble each other, we can measure their vector distances in the space, because similar vectors are closer to each other than dissimilar ones. So the quick question is here actually, what do we mean by visual resemblance or similarity? And instead of categorical data, we now have continuous descriptions of artworks. So here comes another approach to encode images into vector representations without using any black boxes like deep learning. At Kudan, we developed this method to quantify the aesthetic complexity of visual artworks. This was a collaboration with my colleagues Andres Cayus, Marc Hanetzola, Sebastian Arndt from Cambridge University and the Alan Turing Institute, as well as Maximilian Schisch. So yeah, what we are basically doing is we take an image, we transform it. So in this example, we make it blurry. Then we compress them by using lossless compression algorithm. This is, for instance, something you can find in a GIF file format, which leaves statistical redundancy out, or if you will, visual information. So we produce two different file sizes, and the ratio of both is a value that represents one dimension. And then we can do this with many different transformations. Yeah, after decomposition, we produce again these long vector representations. The great benefit is that we actually know what's happening in the background, while especially deep learning methods are extremely difficult to interpret, if at all. And then when we embed these compression ensembles, as we call them, we can again do some neat operations in the multidimensional space. Artworks that resemble each other would be closer together, forming, with our method, clusters of aesthetic complexity. And this time we actually can explain it. On the left side, you can see examples of artists' careers over time. At the top, for instance, I hope you can see this, we identified a career type where in the beginning an artist would produce works that were very typical for the time. So they would paint similar to their peers, but later in their careers they anticipated the future, and their works became ahead of their times regarding the overall aesthetic complexity. So artists like Mondrian or Rothko belong to this type. One underneath is another type, another career type, including Frida Kahlo or Cézanne, who started quite old-fashioned, recapitulating the past, and then became contemporary, slightly ahead of their times, being innovative forces in a very versatile fashion. I will show you now the two demos. So I have to switch for a second. So the first one is, I will show you two very quickly because I don't have so much time. Two demos of interactive tools I'm working on. Both came out of the desire to better understand and gain some intuition over high-dimensional spaces and reduction methods. The first is a little visualization tool I developed that got inspired by brain scan imaging. So here we see the embedding space of 50,000 artworks from the Tate Modern Collection using ResNet 50 for the feature extraction, and UMAP projections in 2D, 3D, and 6D from all angles. And with the interactive slider, this is actually a slider in the middle, we can slide through the embedding space. This I should explain this. This slider is this is one dimension. It's one of the principal components. I explain what this is. So, principal component analysis (PCA) is a linear transformation of the data into new coordinates and can be used for dimension reduction. And UMAP is a nonlinear graph-based reduction method. So we have again networks in the background trying to preserve the structures from the higher dimensions as much as possible. So you can see how in 2D and 3D slicing through the component looks almost linear, but if you look at the bottom at some 6D angles, it becomes evident that the topology is manifold with a lot of intertwinings. So if you stay long enough, maybe you start seeing in higher dimensions. How do I do this? Ah, yeah. So the last project I will show you today is the Collection Space Navigator. This is an interactive tool to navigate large image collections, and we also developed this at Kudan. It's a collaboration with Mark Hanetzola and work in the background with Andres Cayus and Maximilian Schich. It also runs in the browser, so locally or online. You can fully customize it, use your own data sets and projections, and tailor the interface basically to your needs and your specific research question. In this example, we wanted to better understand the multidimensional compression space from our project earlier. So here in the center you see the projection area. This is a two-dimensional coordinate system where we can zoom in and move around with some bigger preview on the side and some information on the selected images. Then on the right, we have data and mapping. So this is a sub-sample of the wiki art. These are 20,000 images, 20,000 artworks, and the mapping is UMap here. We can also use another mapping, for example, T-SNE. And note in the transition how this reveals also some information that is not possible, like static or on paper. Or for example, the first two principal components. Or for example, the first component and time. So this is like this is basically the overall compression over time. You can see how like in the last few decades it spreads out a lot. Then we have these range sliders. Let me switch again. These you can assign to any one-dimensional information. For example, time. So on the bottom we have years. So I can, for example, only look at, let's say, the last century, and can filter these out. And you see some histograms above these sliders that reflect the distributions of the artworks, of the images. We can also click into it, and then we see what's actually in each bucket. And we can also search and query filter some stuff. Let's look at portraits. I think I should end now. And then it filters out. Oh, it filters out. Now we only look at the portraits. So in this use case, we really wanted to gain this intuition about our compression space. So that's why we assigned the first 5 principal components to play around with it. And the idea is that with interacting with it and playing around, you really can get some sense for it, because it's really hard to envision more than 3 dimensions. So it's really not that easy to communicate this with you. Just watching it, you really have to do it and use your hands with it and play around. I think that's it. Thank you.
Thank you, Tillmann, for the insights in a multi-dimensional space of arts and curation. Thank you for feeling very silly that I actually wrote my thesis myself. Not going to do that again. Are there any questions to this presentation? Francis.
Thanks, Tillmann. Great talk and very diverse, and I think I would have loved to hear for each of the examples like 30 minutes presentation. Especially with this representation, and this picks up on a discussion we had, informal discussion we had yesterday. I was wondering what your comment is on the question, what do we see here? Is this a diagram, And if it is a diagram, what does it show? My idea is it may show the collection, but my other hunch it shows the model. So of course it's probably both of them.
Yeah, I just want to say it's a combination of both the method you use to produce the embeddings, the method you use to reduce these the multiple dimensions into just two here, and also the collection you use. I mean, technically, this is like a two-dimensional scatter plot, so you can like as you see here in these first principal component and oh no, this is wrong. Over time, so this is just some statistical information and years. So you can basically do any kind of a two-dimensional map, two-dimensional plot. Yeah, what do we see here? I think that's really important to keep in mind that there are multiple layers of bias or selections going on. So it's a data set that, of course, in WikiArt, it's really Western focused. Then we also need to have the copyrights in some cases, like look for open domain. Then the methods, they are always just the interpretation of these. No, actually, one before it starts with the digitalization of the artwork, which reduces some. It's just interpretation of the real artwork. Then with this interpretation, we do another interpretation by turning it into numbers, and then again, when we embed this in the space, and we reduce the dimensions into these two, we again do some interpretation. So this makes it quite hard to make really strong claims in this space. It's I think that's my access to it. I'm just trying to find ways to navigate in these spaces and to have fun with it, maybe.
Having fun. Next question. Oh, there's several.
Hi, thank you so much for your talk. I would like actually to go back to the beginning of the talk and more that first stage of developing ARCU. And if you can just tell a little bit more about the responses you had online as the project kicked off. And I think that ties to a larger question about the circulation of your work, how it has evolved, and the kind of constituencies you're interacting with since you started.
I think I'm using often technology to hide behind it. So ARCU was actually very useful for me to create some professional network. So I'm always bad at networking, and ARCU was basically doing this for me by going out on Twitter and connecting to all these artists and curators and scientists working in this field, because they would just follow ARCU after a while, and then maybe they would also follow me. And I think it really depends who is in the audience. So sometimes it's the reaction is, oh my God, how can you automate something such human than creating art or curating art or communicating with people even. This should be some kind of provocation. I think that's what an artist should do. And then on the research side of my work, like this, for example, it's more about how can we actually produce some more useful applications for the field.
Did you get some provocative response in the kind of first phase of launching ARCU? Like, sort of, was it just people starting following you, or really engaging and kind of provoking back to the premise of what you were doing?
Yeah, I mean, it starts by retweeting each other's posts, basically. For the creation thesis, it was a little bit different. I'm calling it ARQ. This is like the whole system, but of course, obviously, these are a lot of different things that just together forms an artificial curator. And yeah, for the graduation committee, it seemed to be enough. So yeah, but this was also like 4 years ago. So this is, I don't know, I would use now probably a lot of the things we saw yesterday by Mattis, more advanced approaches.
All right, there was a, yeah.
Hi, thanks for your talk. My question is also concerning RQ, and I was wondering if there were some connections that the AI found between artists that no human curator would have thought about, and maybe even provocative ones or interesting ones. Were there some really interesting takeaways from these machine curations?
I think in the status, or like in the phase before, it's just repeating the structures that are actually already there. So it's basically following the bias that we have. So these AI art scene is a lot based like in the UK, in the US, in Europe. But of course, that's not true. There's a lot happening in other places we just don't hear so much about. So in that sense, Aki just repeats what is still what is still like known in the Western Twitter universe, and but now in the next phase, it's actually the idea is to make a kind of a search engine out of it. So often curators would tell me that one really important or very useful tool would be to find. So, for example, you have an exhibition and you also want to include some female artists from Africa, but you don't know any. So, how to get actually like in contact? And so the idea is that through the information arc you can get from basically scraping or like crawling the whole internet to make these connections happening, which are right now not that strong, at least in the AI art scene. But this is more something that for the next month, next years.
Month and years. Oh, there's one more question in the back. Marlon, could you bring like the microphone? Oh, you have a second one, even better.
Thank you for your talk. My question is, do you think there will be a renaissance of these old school computer vision algorithms to take control back from this black box concept in the future?
Yeah, this black box aspect is, I mean, this is well known and a lot discussed in any field where you use these, or hopefully where you use these models. And a lot of really smart people are working on how to make these models more explainable. And yeah, like the method I showed you earlier with this compression, so you do something really simple that produces something that works for our use case in the same way deep learning produces these vectors. So we don't have to use them, and we can actually understand why is something maybe look odd, and we can explain it. But yeah, I think there will, of course, I mean, now with DALL-E and stable diffusion and this will definitely like have a huge impact on creative output in the next years to come. There will be again a wave, probably even more back to pen and paper and analogous production. But yeah, of course, why not also old school coding and hacking? I hope so.
All right. Are there any other questions? There's one in the front row here. Not front. Third from the front.
Thank you very much, Tillmann, for your very impressive talk. I have a question regarding... Okay, I'm having a question regarding the collection space navigator. So it's very impressive, first of all, and I think it's a rather tool which can be used for research. Do you also see practical applications for the curatorial process and for collection management?
Yes. I think the interesting part about the tool is that you can use it for any use case or for any domain and research question. So this is just something we use in our lab for. But sure, as a curator, if you know how to do it, or you have people who can help you with to produce multiple embeddings and different methods that would, for example, look at the styles, look at the compositions, look at different aspects of an artwork, and you all put them here, and you can just switch between them, and you can see actually how they are connected to each other, especially with the sliders. I think that's really, really useful to understand your collection better, and to maybe find stuff in there you missed.
Thank you.
I hope this answers the question.
Yeah, more or less.
Finding stuff we missed. Did we miss on anything you want to ask? No? Okay.